Good morning, friends. So today we're gonna learn about Boyle's law. So it's this topic is at gas laws in class 9 ICSE chemistry. So let us learn about Boyle's law. The full name of Boyle is Robert Boyle, and starting with Boyle's law is we should know before Boyle's law what that law which is found. It is always found in constant temperature. This is very important because in question numericals when you will get in that time you can easily distinguish to apply Boyle's law by whenever it is written absolute temperature, suppose constant temperature, or the temperature anything is written that temperature is constant. That means over there Boyle's law only will be applicable. So let's start. So Boyle's law is told by Robert Boyle. So he studied extensively the behavior of gases at constant temperature in 1662 and established a relationship between their volumes and pressure. So Boyle law he studied about the gas behavior in 1662 and he postulated some of the relationships between the volumes and the pressures. So what are the experimental studies of the behavior of gases revealed by Boyle are that first is that when pressure on a fixed mass of a gas at constant temperature is increased, the volume of the gas decreases correspondingly. This means suppose if you this means when pressure is increased, the volume automatically means gets less. Okay, this for example, suppose if we take a can, okay, suppose take a can, I am telling, suppose take a Pepsi can or any can, right, any steel can, okay, suppose we get in the market. Suppose when you drink it, can, this is can, okay, so when you drink it, after that when it's empty, when you compress it, after that it becomes like this, it becomes when it gets compressed it becomes like this chapter type. That times what you applied pressure, therefore now how much, suppose over here it fitted to 50 ml. Now if we put water over here only, suppose 20 ml will fit. Okay, so what happens due to the pressure the volume decreased. So by this fact we can say that that whenever pressure is increased, volume gets decreased. This is the first postulate what he said. Secondly, what he told Boyle, when the pressure on a fixed mass of a gas at constant temperature is decreased, the volume of the gas increases correspondingly. That means from when suppose in a body, if the pressure is decreased, at a constant temperature, the temperature should be constant, then the volume increase. Okay, then the volume increases. This is very important, this you have to remember. So what are the 2 points, you can just write it, that I'm just dictating. When the pressure on a fixed mass of a gas at constant temperature is increased, the volume of the gas decreases correspondingly. Yes, so for the example of the number 2 example, suppose a blue whale, suppose a blue whale, inside water it is a great pressure at the depth of water, right? Suppose this is the water, okay, so this is the sea, suppose this is the sea, okay, and this is the seashore, okay, this is the seashore. Suppose over here the blue whale, okay, excuse me, so here the blue whale, here the pressure is very high, okay, but when it comes at the seashore or in the beach, that time it gets, you will see it gets inflated, because over here the atmospheric pressure is very very low as compared to the water, so it gets inflated. That means volume increases of the blue whale in the due to the decrease in pressure. So this example can fit in the number 2 point what I said. Now you can simply note what does the Boyle's law says. Now the Boyle's law says the volume of a given mass of a dry gas. So why dry gas? Suppose we can't take actually moist gas. Moist gas over there water also contains, and water the reaction will not take place. I mean that means this formula will not act over here, because the volume, in the volume water also will be contained, then gas also will contain, then there will be a problem. For that actually dry gas only required. Okay, dry gas is inversely proportional to its pressure, provided that the temperature remains constant. Okay, so this means what, that volume volume is directly proportional to 1 by P. 1 by P means pressure. Okay, this is Boyle's law. Okay, so volume is inversely proportional to pressure. That means with the increase in volume, pressure will decrease. With the increase in pressure, volume will decrease. Understood? These two. Now suppose, now if we want to remove this, so this is what proportional sign. So to remove, we have to bring a constant. Suppose k will bring a constant and 1 by p, so it becomes what, v is equals to kp. Okay, kp, k 1 by p it becomes. Okay, now let's understand, let's derive once what is the exact derivation of the formula, to which equation through which we can write the formulas. That means with which way we can do all the mathematical problems regarding this Boyle's law. Now see, this what I wrote, I brought k, right? So from here I can write v is equals to kp, right? 1 multiply I did over here, so kp I can write, right? V is equals to kp. Now if I write kp, you know vp is equals to k. We can write volume into pressure is equals to constant. So remember this. Suppose this is equation 1. Okay, so now let's move on and just derive the formulas through an example. So now let's do. Suppose a temperature, suppose now come over here. Okay, now suppose a temperature, okay, T. Suppose the temperature is T at temperature T. Okay, this is temperature. Okay, temperature. Okay, now the volume is what, V1. Let the volume be V1 of a body, okay, of a gas. Suppose V1 is the volume, and the volume of a given mass of the gas at pressure V1, and let the pressure be P1. Okay, and V2 is the volume of the same mass of gas at pressure at V2. Now the same thing. Okay, now see, now what is that? Now we can see, we know that Vp is equals to K, right? Now suppose over here what we can get, suppose we can get that Vp is equals to K, we get from this formula, right? Suppose, and then now the new pressure, now the new volume is V2 and the new pressure is P2 of a body or a gas. Okay, suppose, okay, now the volume is V2 and pressure is P2. Similar way we can also write, like last we did that. Suppose now is what, V2 is equals to K, okay, into 1 by P2. Okay, so what happens over here, V2 is equals to K by P2. Sorry, P2. Now we can write V2 P2 is equals to K. So this is the new formula. V2 if the volume is 2 and the pressure is suppose 2, new volume and new pressure. And suppose if the initial is V1 and P1, from here also we can write, suppose V1 is what, volume we can write as K into 1 by P1. So from here I can write V1 and KP1, you know already why it is. And now you can actually write that V1 P1 is equals to K. So see, in both the cases V1 P1 is equals to K, over here also K. So that means one, suppose over here, suppose A is equals to B, and suppose A is equals to B and B is equals to C. And suppose not this, sorry. Suppose now see, over here see, two values are only equal. V1 P1 is equals to K, V2 P2 is equals to K. That means what, these two are also equal, right? Suppose if A is equals to C and B is equals to C, then obviously A is equals to B, right? A is equals to B. Similar way we can also write from here, these two we can write V1 P1 is equals to V2 P2. So this is the equation through which you can find the required volume or pressure in various numericals regarded to Boyle's law. And remember, this is at constant temperature. So this is proof, this equation. Now let's understand by the graphical representation of Boyle's law. Okay, so I have a Nagin book over here. So so let us see graphical representation of Boyle's law. In this, what happens? Suppose, see, over here pressure is increasing, volume is increasing. Suppose over here pressure is, suppose, 1, okay, 2, and volume is over here, suppose 20, 30, 40, suppose 40. Then means what? See, in pressure 1, volume is 40. In pressure 2, that means pressure increased, that means volume also will decrease. Then pressure, the volume becomes what? Suppose over here is 30. So suppose now in pressure, suppose over here is 6, it becomes 20. That means what? With the increase in pressure, volume is decreasing, right? So this way, this is the first V plus V versus pressure. Okay, this is the first one. Now let's do with the second one, plots of 1 by P. Okay, now over here, see, now here is what happening. We know, right, V is directly proportional to 1 by P. That means what? Volume is inversely proportional to P, but directly proportional to 1 by P. That means with the increase in 1 by P, volume also will increase. Same way, this also, this is the, like this happens. Understood? Over here, V is not compared to only P. This is 1 by P. That means what? V is directly proportional to 1 by P. With that means, if the 1 by P increases, volume will increase. If volume is decreases, 1 by P will increase. Similar, that is why it is like straight. Okay. In the third graph, see, PV and P. PV versus P. So straight line parallel to origin intercept. So what? See, by the formula what we derived, lastly what we did, we find now PV is equals to constant. We find now, that means what? If it is compared to now pressure, so with the increase in pressure, suppose over here, this value will not change. As it is a constant, so if the pressure is increased also, the value of PV will not change because it is a constant. So these were the graphical representations of Boyle's law, which I explained, and the experimental verifications of Boyle's law, and the significance of Boyle's law, and certain numericals will be solved in the second part of the video. So stay tuned with the channel. Thank you.